In order to add or subtract fractions, we must have a common denominator. A common denominator is a number that is divisible by each fraction's denominator. One method of finding a common denominator is using prime factorization. To illustrate that, let's look at this first example. We're going to take 8 and find the prime factorization. 2 times 4 is 8, and 4 breaks down into 2 times 2. 12's prime factorization is 2 times 6, and 6 is 2 times 3. So there's the prime factorization of those denominators. Next, choose one of these factorizations. So I'm going to choose the 12 factorization. 2 times 2 times 3 is 12. Then I'm going to multiply that factorization by any factors of the other denominator that it lacks. So 12 has a 2, it has a 2 of 8, but I have a 2 that is not part of 12, and I'm going to include that in that product, resulting in, when you multiply these together, we have 24. This is going to be our common denominator. Our mission then is to find an equivalent fraction for each one of these that has a denominator of 24. So I'm going to take 7/8, and to get a denominator of 24, I need to multiply 8 by 3. To maintain equality, I'm going to multiply the numerator by 3, since 3 over 3 is equal to 1, but the result will give us a denominator of 24. Likewise, 5/12, we now want a denominator of 24. We'll multiply it by 2, but so that we have an equivalent, we will also multiply the numerator by 2 as well. Since 2 over 2 is equal to 1, we're not changing the value. Simplifying these fractions, we end up with a 7 times 3 is 21 over 24, plus 5 times 2 is 10 over 24. We now have the requirement for adding fractions or subtracting fractions of a common denominator, which means we will go ahead, add the numerators over the unchanged common denominator. And simplifying, we end up with 31 over 24. Here's another example, and we'll follow the same procedure of finding a common denominator using prime factorizations. 8 breaks down into 2 times 4. 4 is 2 times 2, so there is our prime factorization for 8. 5 is a prime number, and if we pick one of these factorizations, for example, if we start with the 2 times 2 times 2, the prime factorization of 8, it is lacking the 5, so multiplying that factorization by 5 leads us to a common denominator between these two values of 2 times 2 times 2 times 5 of 40. The next step is to get a common denominator of 40. So we will come up with an equivalent expression for each one of these fractions. To get a denominator of 40, our 9/8 needs to be multiplied by 5 so that we have equivalent. We'll multiply the numerator as well. 5 over 5 again is 1. Likewise, with the second fraction, we want a denominator of 40. To achieve that, we will multiply the denominator by 8 to give us the 40, and to have an equivalent, we'll multiply the numerator by 8. This is equivalent to 1, which isn't going to change the value but give us an equivalent expression. Simplifying these, 9 times 5, multiplying the numerators together, we have a 45. 8 times 5, 40. Simplifying the second fraction multiplication, 4 times 8 is 32. 5 times 8 is 40. We have the desired common denominator. We will then subtract the numerators over that common unchanged denominator of 40. 45 minus 32 is going to simplify to give us 13 over 40, our result to this subtraction of fractions.